Before we just jump into this one with some computations, notice something. You see this second equation here? Compare it to the first. Now maybe you might have noticed this as you write it, but look at this. Look at these coefficients. Every one of these on this side here, on the left side, is negative double the one above it, right? Times -2, times -2, times -2, but not times -2. So what's going on here is that you have almost a multiple of the first equation. So it's like negative double, negative double, negative double, don't negative double. Now when that happens, this means that two of those planes are parallel, at least two are parallel, and there was going to be no solution. So even before I do any work, I can see what's going to happen here, and as you start doing these, you're going to start looking for this kind of thing too. So just quickly, again, if on the left side you see like multiple, same multiple, same multiple, different, then there's no solution. If, though, it's the same multiple all the way through, like double, 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 or triple, 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 then there's at least two coincident planes and there's no unique solution. We'll do one of those next. But for right now, suppose that you didn't notice this and you just start your computations. So maybe here's what you're thinking. Let's eliminate z, and I think what I'll do is I'll use 1 and 2 and then 1 and 3. So I'm going to number these. That's equation 1. The middle one will be equation 2. Third one, equation 3. So I'm going to eliminate z. Now I'm just picking z. You could just as easily go for y or x. I just happen to pick z. It's just the way I do it. So I'm going to eliminate z using, if I can get it to right here, using equation 1 and equation 2, then equation 1 and equation 3. So first up, let's use 1 and 2, and then 1 and 3 to eliminate z. So let's start here using 1 and 2 to eliminate z. And that will get us x and y. Makes sense? If we eliminate z, we'll be left with x and y. So focus in on these coefficients of z's. Now they're already opposite signs. We just need to get the same number. Well, the smallest number they both divide into is 6. This is already a 6. I just need to multiply that by 2, but I have to multiply the entire equation by 2. So here's the plan. How about if we take 2 times equation 1, add that to equation 2. And doing so is going to give this. Now take that 2 and multiply it through every one of those 4 terms that are in equation 1. We will get, but I'm multiplying by 2. So how about negative 2x plus 8y minus 6z equals 4. Let me just check that multiplication. So I'm multiplying by 2. So negative 2, yeah. Positive 8, yeah. Negative 6, okay. And 4, got it. And then equation 2, no change. So that's just 2x minus 8y plus 6z equals 1. And when we add these together, look what happens here. The x's are gone, the y's are gone, the z's are gone, so we're left with 0 on the left side, 5 on the right side, which of course is false. And as soon as you get a false statement, you can say that there is no solution to this system. Now geometrically, if these were lines, if we just had 2 variables, we would have parallel lines. But these are 3 dimensions, so we have planes, so there's at least 2 parallel planes. So we eliminated all the variables, got a false statement, so no solution, and that's what we expected up here, right? Because we were writing this, we could kind of see that on the left side we got negative double, negative double, negative double, not negative double.